Hello friends, I am Dr. Satish Chauhan, your chemistry teacher. In this video, you will learn the chapter 2, Introduction to Coordination Chemistry. In this video number 1, we will consider various terms and definitions involved in coordination chemistry. Coordination compounds or complex compounds. A coordination compound is a complex compound in which a central atom is bonded to the group of molecules, atoms or ions. The extra group or ions are attached to the metal M by coordination bonds, which the attached group, that is ligand, is the donor. For example, potassium ferrocyanide, where M is the Fe is the metal, that is M, and Cn is the ligand. The usual valency of Fe is 3, but it forms 6 bond with the Cn minus ions. The coordination compounds may either be cationic, anionic, or both, or sometimes neutral. Complex cation, CuNH3 twice. Complex anion, FeCN6 3 minus. Complex cation and anion, CONH3 6 plus 3, CrCN6 minus 3. Neutral, CONH3 Cl3. Double salts. Double salt is the mixture of two different simple crystalline salts. A salt that crystallizes as a single substance but ionizes as two distinct salts when dissolved in water. For example, carnallite, KMgCl3 6H2O. FAS, ferrous ammonium sulfate, FeSO4, NH4 twice SO4 6H2O. Potash alum, K2SO4, Al2SO4 thrice 24H2O. The compounds like potassium ferrocyanide K4CN6 are called as coordination or complex compounds because in their aqueous solution they lose their identity and do not show the test for individual ions like Fe2 plus and Cn minus, but give the test for K plus and FeCN6 4 minus ions. Comparison of double salts and complex salt. Double salt. Double salt exists only in crystalline state. Here, complex salt exists both in crystalline and solution states. Number 2, all constituent ions can be detected. All constituent ions cannot be detected. Individual components do not lose their identity in the solution. Individual components lose their identity in the solution. Absence of complex ion, presence of complex ion. Examples: carnallite KMgCl3.6H2O, potash alum K2SO4 Al2SO4 thrice 24H2O. Here example of complex salt: potassium ferrocyanide K3FeCN6, hexamine cobalt 3 chloride CONH36 Cl3. Complex ions. A complex ion is a charged species formed when a metal atom or ion is directly attached to the group of neutral molecules and or ions are called as ligands. The complex ion is indicated by enclosing the formula for the ion in the square bracket. Cu NH3 4 twice neutral ammonia molecule are attached to the Cu2 plus ion. CONO2 6 3 minus negative NO2 minus NO2 2 minus ions are attached to the cobalt 3 plus ion. And number 3 CONH3 Cl3 both negative Cl minus as well as neutral NH3 molecules are attached to the CO3 plus ion. Central atom. It is the metal atom generally present in the neutral coordination compounds to which two or more neutral molecules are attached. For example, NiCO4, FeCO5. In these examples, neutral CO molecule are attached to the Ni plus ion and Fe2 plus ion. Central ion. It is the metal ion in the complex to which two or more neutral molecules or anions are attached. For example, in complex CONH3 Cl2 plus, the cobalt ion is the central metal ion to which 5 NH3 molecules and 1 chloride ion are attached. Ligand. Any atom, ion or molecule which is capable of donating a pair of electrons to the central metal atom or ion is called ligand or coordinating group. Ligand contain electron pair known as donor atom or donor site. If the ligands contain only one donor atom that is capable of forming one coordinate bond to the central metal atom or ion, then it is called as monodentate or unidentate ligand. If the monodentate ligand may simultaneously coordinate with two or more metal atoms, thus they are called bridging ligands, and complex thus formed is called as bridged complex. So, monodentate ligand Cl, FeCl3, FeCl3. So, this Cl minus forms bridge between those two FeCl3 molecules. So, therefore, this complex is called as bridged complex. Depending upon the number of donor sites, these ligands may be classified as bidentate, that is 2 donor sites, tridentate, that is 3 donor sites, tetradentate, that is 4 donor sites, and so on. A Lewis base which donates 2 lone pairs of electrons to the central metal atom is known as bidentate ligand. They are often referred as chelating agents. The complex which contain chelating ligands is called chelates or Krebs claw. So, this is ethylene diamine which donates lone pair. This NH2 donates lone pair to metal. This also donates to metal. So, ethylene diamine is a bidentate ligand. This is cobalt ethylene diamine 3 plus complex. Some monodentate ligands. So this is the chart. Fluoro, IUPAC fluoro, F minus. Then we have chloro, bromo, iodo, azido, cyano, like that. These are the monodentate ligands which are able to donate only one lone pair of electrons to the central metal atom. So therefore these are called as monodentate ligands. Bidentate ligands, some bidentate, tridentate, tetradentate ligands and polydentate ligands, ethylene diamine. So two donor sites, so therefore bidentate. 2,2-dipyridyl, two donor sites. Then we have glycine, again we have two donor sites. Coordinate or dative bond. Coordinate bond is a special type of covalent bond in which two shared electrons are contributed by only one of the two atoms linked together. The atom contributing the electron pair is known as donor, while the atom which accepts this electron pair is called as acceptor. The coordinate bond is usually shown by short arrow. The arrowhead is directed from the donor atom to the acceptor atom. Coordination number. A number of ligands which are directly attached to the central metal atom or ion is known as coordination number of the complex.